let's look at what is the Ohm's law. We have seen that when a battery is connected across a conductor, electric current begins to flow through it. How much current flows through conductor when a certain potential difference is set up across its end? The answer to this question was given by German physicist Georg Siemens Ohm. He showed by elaborating experiment that the current through a metallic conductor is directly proportional to the potential difference across its ends, and the fact is known that the Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across its ends, provided by the physical state such as temperature, etc. of the conductor remains constant. Symbolically, Ohm's law can be written as I is directly proportional to V, so it implies that V is equal to Ri, where R is the constant of proportionality called the resistance of the conductor. Value of resistance depends upon the nature, dimension, and the physical state of the conductor. In fact, the resistance is measure of the opposition to the motion of electrons due to their continuous bumping with the atoms of the lattice. The unit of resistance is ohm. Conductor has a resistance of 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is applied across its end. The symbol of ohm is this, and if I is measured in amperes, V in volts, then R is measured in ohms. R in ohms, V in volts, and I in amperes. A sample of conductors said to obey Ohm's law if its resistance R remains constant, that is, if the graph of the V versus I is exactly a straight line. A conductor which strictly obeys Ohm's law is ohmic. However, there are devices which do not obey Ohm's law and are non-ohmic. The example of the non-ohmic devices are filament bulbs and semiconductor diodes. Let us apply a potential difference across the terminals of a filament lamp and measure the resulting current passing through it. If we repeat the measurement for a different values of potential difference and draw a graph of voltage versus the current, it will be seen that the graph is not a straight line. It means that a filament is non-ohmic device. The deviation of IV graph from straight line is due to increase in the resistance of the filament with temperature, a topic which is discussed in the next section. As the current passing through the filament is increased from 0, the graph is a straight line in its initial stage because the change in the resistance of the filament with temperature due to small current is not appreciable. As current is further increased, the resistance of the filament continues to increase due to its rise in temperature. Another example of non-ohmic device is a semiconductor diode. The current voltage plots of such a diode is shown in the figure 13.9. The graph is not a straight line, so its semiconductor is also an non-ohmic device.